Number 3, solve the nonlinear system x squared minus y squared equals 21. X plus y equals 7. To solve for the values of x and y in this nonlinear system, we apply the substitution technique. So let x squared minus y squared equals 21 be our first equation. X plus y equals 7, second equation. Now, from equation number 1, we can solve y or x in terms of the other variable. Let's say we want to solve for y in terms of x. We get y equals 7 minus x. This is our third equation. Substitute this y to the y of the first equation because we get it from equation 2. Okay? So this is from equation 2. So from equation 1, x squared minus y squared equals 21. Substitution gives us x squared minus 7 minus x quantity squared equals 21. Copy. Then we square this. Now, after squaring, we change the sign of every term. So minus 49. So this gives us negative 14x for the middle term, but preceded by negative, so positive 14x. Positive x squared minus, therefore negative x squared equals 21. Collecting similar terms, first term and last term on the left side are eliminated because they are additive inverses of each other, meaning giving 0. So hence we have 14x on the left side, and then on the right side, 21 plus 49, getting 70. Divide each side by 14, we get 5. So this is the value of x. Now what about for the value of y? For the value of y, we solve it from equation number 3. Y is equal to 7 minus x, but x is equal to 5. Hence, we have y is equal to 7 minus 5. Therefore, y is equal to positive 2. So, we can express our answer, final answer, in terms of ordered pair of numbers. So that is 5, 2 as coordinates. So hence the answer is the point 5, 2. Let us have number 4. Solve for x in the equation 11 over 6x plus 1 is equal to 2 over x plus 1. So the given is 11 over 6x plus 1 equals 2 over x plus 1. First step is to get rid of the denominators on both sides. Okay, so we multiply each side by 6x plus 1, x plus 1. On the left side, we have 11 times x plus 1. So 6x plus 1 is cancelled. On the right side, we have 2 times 6x plus 1. So this time, x plus 1 is the one that is cancelled. So distribute 11 to its term inside, getting 11x plus 11. On the right side, we get 12x plus 2, 11x minus 12x. On the right side, we have 2 minus 11. So this is negative x. On the right side, negative 9. Therefore, x is equal to 9. After multiplying this equation by negative 1. So the root for the solution to this equation is x equals 9. So we accept this value since this value is in the domain of the equation. Number 5. Given 2x plus 1 all over 3x plus 4 equals 3x minus 1 all over 9x minus 8. Find the solution set. So given this equation, first step is to simplify. We can simplify this by multiplying both sides by 3x plus 4, 9x minus 8, so that denominators are eliminated. On the left side, 3x plus 4 is cancelled out, getting 2x plus 1 multiplied by 9x minus 8. On the right side, 9x minus 8 is the one that is cancelled. So 3x minus 1 multiplied by 3x plus 4. On the left side, multiplying these binomials, we get 18x squared plus 9x minus 16x minus 8. On the right side, we have 9x squared minus 3x plus 12x minus 4. So expressing everything on the left side, we get 18x squared minus 9x squared. For linear terms, we have negative 7x, and then here minus 8. Linear here is positive 9. Then expressing it on the left side, we have negative 9x. And then this is minus 4. Okay, now this is factorable into two binomials. The first binomial is 9x plus 2. The second one is x minus 2. So let's check. 9x squared, negative 18, positive 2, so negative 16, then negative 4. Okay, so equate its factor to 0. For the first linear, solving for x, we have 9x equals negative 2. X therefore is negative 2 over 9. While here, on the second linear, x is equal to 2. The domain of the equation is the set of all real numbers except negative 4/3 and 8 over 9. Therefore, we are going to accept these values. The roots are negative 2 over 9 and x equals 2. So finally, the solution set is a set containing negative 2 over 9 and 2. Okay. So therefore, this is the final answer. So this is the solution set. For number 6, we have about inequality. Determine the solution set of the rational inequality one over x minus 2 is less than or equal to 3 over x plus 4. 1 over x minus 2 is less than or equal to 3 over x plus 4. So let's add on its side negative 3 over x plus 4 to get 1 over x minus 2 minus 3 all over x plus 4 less than or equal to 0. Again, we add on its side negative 3 over x plus 4. Combining these two fractions, we get x plus 4 minus 3x plus 6 all over x minus 2 x plus 4 less than or equal to 0. Simplifying the numerator, we get 10 minus 2x all over x minus 2 x plus 4 less than or equal to 0. So this is now in the standard form. So meaning left side less than or equal to 0. Let's get the critical numbers. Critical numbers are the zeros of the numerator and denominator. For the numerator, we have 10 minus 2x equals 0, getting x is equal to 5. And then for the denominator, we have x is equal to 2, x is equal to negative 2. So let's arrange these critical numbers on a number line. Take note that since this is less than or equal to, meaning equation is part, so x equals 5 is part of the solution set, but x equals 2, x equals negative 4, never. So not solutions. Okay? Or not part of solution set. So let's have number line. We arrange the three numbers from lowest to highest. Negative 4, positive 2, then 5. So this is going to be positive infinity to the right, negative infinity to the left. There are three expressions to consider, one in the numerator and two in the denominator. So the first expression, 10 minus 2x. The second one is x minus 2. The third is x plus 4. This 10 minus 2x is equal to 0 when x is 5. So we're going to mark 0 here. And then x minus 2 is 0 when x is 2, while x plus 4 when x is negative 4. We want to know the signs of this expression in every interval. Here, negative, positive, 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 because, and here negative, because the coefficient of x is negative. So here negative, negative, positive, positive, positive coefficient. So the third one is positive coefficient or negative, positive, positive, positive. We want to get the quotient with the following signs of the numerator and factors in the denominator. So for the quotient, sign of quotient, we get positive, negative, positive, negative. We want less than, so we consider the following intervals. So the following intervals here. So solution set, therefore, interval negative 42, but take note, we don't include negative 4 and 2. So open interval negative 4, 2 to 2. Union with 5 is included. So from 5, use bracket to positive infinity. So this is the solution set. Number 7. Given f of x is equal to x plus 4 all over x squared minus 4 x minus 16. The numerator has another factor, x minus 5. So find the following. Letter A, holes in the graph of f. Letter B, find the domain of f. Letter C, vertical asymptotes. So first, let us express the numerator and denominator in factored form. So the numerator has no problem anymore because it is already in factored form. What about the denominator? X plus 2, x minus 2, For the second one, we have, I'm sorry, this is supposed to be x squared minus 16. So what's the factored form? X plus 4, x minus 4. So this is canceled out with this. So getting what? Getting x minus 5 all over x minus 2, x plus 2, and then x minus 4. Provided we have x not equal to negative 4. So for letter A, wholes. So the x coordinate of the whole is x equals 4. We can solve for negative 4. We can solve for the corresponding y value of the whole by substituting negative 4 to the simplified equation. So we have y equals negative 4 minus 5 all over. This is negative 4 minus plus 2, I mean. Negative 4 minus 2. And then negative 4 minus 4. So giving negative 9 in the numerator, in the denominator, negative 2 times negative 6 times negative 8. So negative 96. Or y equals, when simplified, 3 over 32. So therefore, the whole is the point negative 4, 3 over 32. Okay. Letter B, domain. The domain of F is given by the set of all real numbers where x is any real number. So again, set up all x such that x is a real number, not equal to what? Not equal to plus or minus 2, plus or minus 4. Okay? In interval notation, we have negative infinity to negative 2, union with negative 2, open interval, negative 4, union with negative, open interval, negative 2, negative 4, union with negative 4 to positive 2, open interval, union with 2 to 4, open interval, union with 4 to positive infinity. Okay? So this is the domain of F. For the vertical asymptotes, we look at the simplified. So vertical asymptotes. We have values of x that will make the denominator 0, we have when x is -2. So x minus equals -2 is a vertical asymptote. Another, we have x equals 2. And then we have x equals 4. So these are the 3 vertical asymptotes. There are 3 vertical asymptotes. For number 8, we have given f of x is equal to x minus 2 all over x plus 3. Find letter A, zeros of f. Letter B, range of f. So to solve for the zeros of f, we equate f of x to 0. So we get x minus 2. So this is for letter A. Zeros of f. We have to equate, again, we have to equate f of x to 0. So getting x minus 2 is equal to 0. X is equal to 2. So the 0, there is only one 0 of f, and that is when x is equal to 2. Letter B. For letter B, for the range of f. Now to get the range of f, let f of x be equal to y. And then we try to solve x in terms of y to get the restriction on y. So we have xy plus 3y is equal to x minus 2. So getting x, y minus x is equal to -2 minus 3y. Factoring out negative x, we have 1 minus y, and that is equal to -2 minus 3y, or x is equal to 2 plus 3y all over 1 minus y. So here, the denominator will become 0 and y is what? 1. So the range, therefore, set of all y such that y is a real number not equal to what? Not equal to 1, or that is negative infinity to 1, but we don't include 1, of course, union with 1 to positive infinity. We don't include 1. So this is the range. Okay. So if you try to check when y is 1, we will not able to get a corresponding value for x. So x plus 3, because when y is 1, we multiply, x plus 3 is equal to x minus 2. So 3 is equal to -2 false. So hence, 1, y equals 1 is not really in the range. 9. Given f of x is equal to square root of 4 minus x squared, if x is between -2 to +2, and then it is x plus 1 if x is greater than or equal to 2. Find the following. Find letter A, domain of f. Letter B, range of f. Letter C, the value of the function when x is 0, the value of the function when x is -3, and the last one when x is +3. We can easily determine the range if we're going to draw the graph. No problem for the domain, we can easily get that. So let's draw the graph. The first one is actually an upper circle. An upper circle. From between -2 so we have between -2 and 2. So this is supposed to be open here. When x is -2, 4 minus 4 is 0. So when x is 2, we have 4 minus 4 is still 0, but still open. Open here. And then when x, so the graph, by the way, the graph is, so when x is 0, we have what? 2. Okay. So we have 2 here. So this is how the graph looks like. Actually, this is upper part of the circle. Then when x is 2, 2 plus 1 is 3. When x is 2, so we have 3. So let me put here 3. So this value aligned here at the height of 3. So this is 3. This is 1. -2, +2. When x is 3, so somewhere here, so the value is 4. So around here. Okay. So around here. So let me approximate the graph here. Okay. So for letter A, domain of F, for the domain of F, we have -2 to positive infinity. We don't include -2. So we have, again, from greater than -2 to positive infinity. Obvious from the graph. For the range of F, we have open interval 0, open, half open, 0 to 2, we include 2. 0 to 2, but there's no graph between 2 and 3. So we have union with, so we start with 3, 3 to positive infinity. So this is the range. We look at the y values. So letter C, value of f of 0. 0 is between -2 and 2. So we are going to use square root of 4 minus 0 squared, and that is equal to 2. F of -3 is is not in the okay, so -3 is not in the domain, no? Therefore it is undefined. What about f of 3? F of 3 is in this inequality, no? When x is greater than or equal to 2. So therefore we are going to use x plus 1. So x is 3 plus 1, and that is equal to 4. So that's the value. Okay. Number 10. Given this graph, is this a one-to-one function? So this is one-to-one. If I have this graph, this function is not one-to-one. Number 11. Which of the following equations, or which of the following functions is a one-to-one, is one-to-one? Letter A, square root of 4 minus x squared. B, g of x is equal to x plus 3 all over x minus 1. C, h of x is equal to x squared plus 4. And letter D, big F of x is equal to absolute value of x. So here, this is half circle. The graph is something like this. So it's not. No? This is not. So what about this? This is a parabola that opens upward. So it looks like this. So not also this one. This has a graph that is looking like V. Okay. So there is only one remaining. Let's check. Now, to determine whether this is one-to-one or not, we assume G of A equals G of B. So we now have A plus 3 all over A minus 1 is equal to B plus 3 all over B minus 1. We will multiplying by the LCD, we have on the left side A plus 3, B minus 1. On the right side, A minus 1, B plus 3. So this is AB plus negative A plus 3B minus 3. That is equal to AB plus 3A, then minus B minus 3. Okay, so this is eliminated. We have negative 3 eliminated also, getting negative 4A equals negative 4B. So A therefore is equal to B. So hence, this is, therefore we say that G is 1-to-1, is 1-to-1. So the answer is B. Number 12. And find the inverse function of f of x equals square root of x minus 3 plus 1 if it exists. So let y be equal to the square root of x minus 3 plus 1. Y minus 1 is equal to square root of x minus 3. Squaring y squared minus 2y plus 1 is equal to x minus 3, squaring its side. Solving for x, we have x is equal to y squared minus 2y minus 4 is equal to 0. Minus 4 plus 4 plus 4. So plus 4. So interchanging x and y, we have y is equal to x squared minus 2x plus 4. Now, this defines a function. Therefore, the inverse exists. Now, and the inverse is given by f inverse of x is equal to x squared minus 2x plus 4. But what is the restriction for x? Where x is what? Now, if you're going to look at the range of this given, the range is 1 to positive infinity. The minimum value of this is 0 plus 1, so the minimum value of y is 1. And then as x increases, the value of this increases. So from 1 to positive infinity. And therefore, x is greater than or equal to 1. Remember, the range of the original function is the domain of its inverse, if inverse exists. So this is the inverse. Given this absolute value function, f of x equals x minus 4. Find minimum value of f. No, so first let's draw the graph. The absolute value of x minus 4 is defined as 4 minus x if x is less than 4. And it is x minus 4 if x is greater than or equal to 4. If we're going to draw the graph has a vertex at 4, and then it opens upward, no? So something like this. When x is 3, 4 minus 1, 4 minus 3 is 1. When x is 3, 1 here. So the graph looks like this. So obviously, f mean is equal to 0. What if I have f of x is equal to negative absolute value of x minus 4 plus 6. If you're going to look at the graph of absolute value of x minus 4, so it's like a b going up, no? V. So since we negate that, we're going to have upside down of this. upside down. 1, 2, 3, 4. So here, and then I'm going to move 6 units upward. 1, 2, 3, 4, 5, 6. So it's something like, so here, the graph is, again, flip this and then move 6 units upward. 1, 2, 3, 4, 5, 6. So the graph is somewhere here. So when x, for instance, is 3, so this is -1 plus 6, I have 5 here. So something like this, and then like this one. Okay, so this is 6. Therefore, if you're asked of f max, f max is equal to 6. What about this? Given f of x is equal to 4 plus 1/3 raised to x minus 3. Determine the following. Letter A, domain of f. Letter B, range of f. Letter C, inverse function of f. So first, domain, letter A. Since this is an exponential function added to a constant, so x can be any real number, or that is negative infinity to positive infinity. Okay? So what about the range? The range of this is minimum value of this is when x is 3, this is going to be 3 minus 3, 0. So the exponent is 0. So 1. Okay? Plus 4 plus plus 4. So when x is 0, the intercepts. When x is 0, we have, but this is asymptotic above the x-axis, so plus 4. So the range therefore is greater than 4. Range, set of all x such that x is greater than 4. So 4 to positive infinity. Okay. Now for the inverse function, so inverse. So first let y be equal to 4 plus 1/3 raised to x minus 3. Solve for x. So solve for x, we get the logarithm of its side to the base 1/3 because the base of this is 1/3. After solving y minus 4. And that is equal to 1/3 raised to x minus 3. So here we have log of y minus 4. and that is equal to 1/3 raised to x minus 3. So, and this is now equal to what? So when changed to logarithmic form, we have base 1/3, and this is equal to x minus 3. Okay? The exponent, the logarithm is the exponent. X therefore is equal to 3 plus log of y minus 4 to the base 1/3. So interchange x and y to get y is equal to 3 plus log to the base 1/3 of y minus 4. Since exponential function is 1 to 1, therefore there is an inverse, and the inverse is given by 3 plus log, by the way, this is x, to the base 1/3 of x minus 4. Number 16. Given f of x is equal to 2 minus log to the base 3 of x plus 1. Find letter A, domain of f, B, range of f. Letter C, inverse function of f. So letter A, domain, for the domain, since this is logarithmic, so x plus 1 should be greater than 0. X plus 1 greater than 0. Therefore, we have x greater than -1. So therefore, the domain greater than -1 to positive infinity. For the range, we have the graph is the graph of log of x plus 1. I mean, the graph of log x to the base 3 is something like this. Okay? But negative, so we're going to flip it. We're going to flip. Okay, so this is supposed to be 1. But we have to move 1 unit to the left. Therefore, we have here. So instead of passing here, so we'll pass here. So something like this. So that's the graph. But we have to add 2. So finally, we have 1, 2. So somewhere here. So the range, therefore, is given by negative infinity to positive infinity. inverse. So for letter C, inverse of f. So let y be equal to 2 minus log of x plus 1 to the base 3. So log of x plus 1 to the base 3 is equal to y plus 2 minus 1. Changing this to exponential form, we have x plus 1. I mean, the base is 3. The exponent is 2 minus y. And this is equal to x plus 1. Solving for x, we have x is equal to 3 to the 2 minus y minus 1. Interchange x and y. Y is equal to 3 to the 2 minus y, then minus 1. So this is a one-to-one function. Therefore, inverse exists and it is equal to, sorry, this is supposed to be 3 to 2 minus x. So 3 to the 2 minus x and then minus 1. So this is the inverse. Seventeen. Solve for x in (27) raised to x minus 1 is equal to 1 over 9 raised to 2 minus 4x. So first we have to express its exponential to power of 3, same power for each side. So this is 3 raised to 3 raised, and this is raised to x minus 1. And then this is 3 squared raised to 2 minus 4x. So getting 3 to the 3x minus 3, and this is equal to 3 to the negative 4 plus 8x. When bring it up, this is 3 to the negative 2 multiplied this, the exponent, 2, negative 2, we get this. So therefore, we have 3x minus 3 is equal to negative 4 plus 8x. So getting negative 5x is equal to negative 1. X therefore is 1/5. So this is the value of x. Okay.